ABCD is a rhombus. Show that diagonal AC bisects angle A as well as angle C, and diagonal BD bisects angle B as well as angle D. So I'll show you guys the diagram. You pretty much have to figure out the rest of it. So again, I'm not going to give you guys any clue, right? You need to figure out what is the property and everything, because that's the whole idea. If I tell you the property, then what's the point, right? So yeah, that is your rhombus ABCD. So we have to show that AC. So we have AC and DB. Okay. So that's your figure. Right. I'm expecting you guys to write the given and what is that we need to prove. Okay. So I hope you guys are able to figure out some properties at least. So let me just, I'll make two diagrams because it will be easy for us to discuss actually. So you need not do so in your exams. It's only for us to discuss. We have AC and BD. Okay. So first thing first, what is given? A very important clue, that is ABCD is a rhombus. So what can we tell? All the sides are equal. I think if you are able to figure out, this part, if you're able to tell this, you're pretty much done. So this implies all sides are equal, and so we can conclude AB is equal to BC, which is equal to DC, which is equal to AD, and let's call them as X. Right? All the sides are equal. Then show that diagonal AC bisects angle A as well as angle C. So when they tell bisects, it means cutting into two equal halves. So basically this is A and this is A, and actually over here too, it will be A and A. So same thing over here. If this is B and B, this too will be B and B. Right? Proving one, you're pretty much done with everything else. So let me directly go to what is that we need to prove. AC bisects angle A and angle C. Then we have BD bisects angle B and angle D. Okay, how will we prove this? So we have and opposite sides are parallel. So AB is parallel to DC and we have AD being parallel to BC. Okay, so these are all the properties that you will need. Right? Okay, now figure it out. So we'll begin with, consider triangle ADC. Angle ADAC, right? I'm talking about this particular triangle. So DAC is equal to angle DCA, and the reason is alternative interior angles. So we already written the opposite sides are parallel. That's good enough. So we'll call let angle DAC, which is equal to DCA, be equal to A. Sorry, not alternative interior angles. Angle opposite to, big mistake, angles opposite to equal sides, right, as AD is equal to DC. Then we'll call that, okay, we call this angles as A. It's going to help. How? So I'll show it over here. Next thing is angle DAC is equal to angle ACB. So this particular angle and this particular angle. Why are they equal? Because they are, and they are equal to what? Equal to A. Alternative interior angles. Now similarly, this two angles BAC and angle ACD, both of them are equal to A, and they are alternative interior angles too. Right, we have written the reason that these things are parallel and everything. So what can you conclude from all of this? This implies angle A and angle C is bisected by AC. So we pretty much prove that the adjacent angles are equal. The neighboring angles are equal. So that means AC has bisected this. As simple as that. Okay. So the next part is on the same line, with the same argument we can write it. I think I'm a bit confused. Should we write this entire thing, or can we just tell, similarly we can prove that. Anyways, they asked us exclusively, so let's do that. Consider triangle ADB. So we will tell angle ADB is equal to angle ABD, right? So again, we are talking about this triangle. If you're not able to, right, have a look at this. Now I think it's clear. These two angles are equal. Reason: angle opposite to equal sides. It's okay. We need not write it. We have written such statements. Then let angle DADB, which is equal to angle ABD, let them be equal to B. And now we can tell angle ADB is equal to angle DBC, which is equal to B. So these two are equal to B. Okay. Again, reason: alternative interior angles. Then angle A, right? These two are done. ABD is equal to angle BDC is 2 is equal to B. So same reason. And since we have the alternative interior angles being equal and thus the adjacent angles being equal, this implies angle B and angle D are bisected, are bisected by BD, are bisected by AC, right? Okay, so that's it. So you can see the power of variables. So if we stick to a particular set of variables, things become very simple to prove. So such question, the fastest way to handle is this way.